Hey class, welcome back. This week we're going to discuss a couple of more things having to do with artificial neural networks. And this will actually be the main video for this week. On Thursday, what I'll do is I will upload some videos describing our final project. As you'll recall that there is no final exam in this class, but there will be a final project that you'll work on as a group. And so on Thursday, I'll link you guys to a rubric that'll tell you, what I want, what I expect on your final project, as well as some other logistical details having to do with that. Okay. But today, what we're going to do is we're going to discuss variable importance with respect to, with respect to artificial neural networks. As you guys probably have noticed, with each one of these models, we've kind of gone through the same sequence. First, we've learned how to use the model. Then we've talked a little bit about the technical details. And then finally, we've learned, okay, well, how do I assess the importance of different variables once I've actually fit my model? A lot of the times, what you're interested in when you're fitting these models is, okay, which of these independent variables are really driving the behavior of the dependent variable. Okay, so let's jump into it, and let's actually just start with a quick review, okay? Last week, we learned that artificial neural networks are a machine learning algorithm, okay, that is a very flexible and powerful new way to analyze data. And the way these artificial neural networks are set up is they're set up in a series of layers. Okay, so here we have this diagram. This is in reference to our housing price data set. Okay, so here we have on the left an input layer consisting of all our independent variables. Okay, those neurons talk to or are connected to two hidden layers. And then finally, these hidden layers are connected to a final output layer. Okay, and the idea here is that essentially we pass in the information corresponding to all of our independent variables. Information is successively processed by these neurons in the hidden layer, and finally they all spit out an output to this final neuron, which will generate our prediction. We also discussed the fact that even though all of the neurons in each layer are connected to all of the neurons in the subsequent layers, the strength of those connections is not constant. It varies from neuron to neuron. And the strength of those connections, called weights, are actually really how the neural network does its information processing. And last week we talked a little bit about, we sort of gave a simplified example of that. So here's a much simpler neural network with only one neuron in its single hidden layer. And we said that, well, how do these weights actually work? Well, it's as simple as taking each input neuron. For example, in this case, I have two input neurons, one for bedrooms and one for age. So imagine that this is a house with two bedrooms that's 10 years old. Okay, we take those input values, we multiply by the corresponding weights, we add this bias term, okay, and this final number gets passed through an activation function. And the output of that activation function is going to govern how strongly this neuron then communicates with the neuron subsequently down the line. Okay. We talked about different kinds of activation functions. Okay, so there are a variety of different types of activation functions to choose from. And we also finally, we didn't go into the details of this, but I mentioned, that this artificial neural network, when we train the artificial network initially, okay, when you guys put in that command neural net, and the computer is, taking its 2 or 3 minutes, processing, you're waiting for it to actually get the result. What it's doing that time, it's training the artificial neural network, and that training process simply involves repeatedly nudging the weights, okay, in order to get the predicted value of the price or whatever it is you're trying to predict as close to the true value as possible. Okay, so with all that in mind, let's proceed to this concept of variable importance. We're going to discuss three techniques for examining the variable importance of an artificial neural network. Two of these will be familiar because they're analogous to what we did for the random forest, and one of them will be new. Okay, so let's start with a familiar one, the idea of importance by omission. So, and this once again is the idea that if I want to know how important a variable is to my model, one way to diagnose that is to simply omit that variable and then to measure the accuracy of the model with that variable omitted and see how much the accuracy fell compared to when the variable was present in the model. And you'll recall that the way we actually do this usually is not by dropping that variable entirely, but simply by scrambling the rows of that variable. If we scramble the rows of a variable, we essentially destroy the information contained in that variable, and that's as good as removing it. And the reason we don't remove it entirely is because we want to sort of preserve the same overall structure of the model. You know, sometimes if you take out a variable entirely, the whole structure of the model might change. And that's not what we want. We just want to see the effects of sort of disabling that particular variable. Okay. So let's see how this is done. I'm going to go into R here. Okay. So what I have here is much of the same code that we've been using before. We need a new package. I'm going to do this install.packages neural net tools. Okay, I've already installed it, but please install it on your computer. Okay, and I'm going to go ahead and load up all of these different packages. And this is the same data prep that we were doing last time. So I'm just going to go through and run all of that. Okay, and then finally I'm going to train my neural network. And let's train this neural network same as last time with 2 hidden layers, each with 10 neurons. So go ahead and run that. While it's running, just a quick recap of these data prep steps. Okay, remember that just, the neural network, it's a little bit more finicky about what we can put in. So we did a couple of things. One is that we scaled the variables, okay, so that all of the variables fall between 0 and 1. And 2 is that, we just went through and we replaced any weird characters in the variable names with underscores. Just some basic data cleaning steps. Okay, and so here we have it. We fit the neural network. Okay, and now you'll recall that that when we were dealing with the random forests and we were trying to use this sort of importance by omission type metric, with random forests we had a package called Random Forest Explainer, and basically there was a package that could do this automatically. For artificial neural networks, unfortunately, I didn't find a package that could perform this measure automatically. And so we're going to have to do it manually. But really, it's not that hard. Okay, so let me run you through the steps of that. Okay, so the first thing that we're going to do is we're going to compute the accuracy with all of the variables in our model included. Okay, so that's as simple as making a prediction. Okay, so you can see here I'm predicting in the test set, and then I'm simply evaluating the error, the mean average percent error, and then I'm going to take that number and I'm going to store it as mean average percent error dot before. Okay, so let me do that. Okay, and if you want to evaluate it, we can evaluate this term, and you can see that our average error before scrambling any variables is around 30%. Okay, so then I'm simply going to scramble one of the variables. And the way you scramble something in R is to use this sample function. Okay, so for example, if I type in 1:10, R will spit out the numbers between 1 and 10. But if I do sample on that same sequence, you can see that it simply scrambles the numbers in that sequence. Okay, so we're going to use this sample function. And I'm actually not going to do it in the test set itself. I don't want to mess up the test set. Okay, so I'm actually going to copy the test set. So you can see I'm saying here test.scramble equals copy test. This simply makes a copy of our test data table. Okay, and then within this test scramble, you can see what I'm going to do is I'm going to take this variable here, living area, and I'm going to scramble it. So I'm going to say living area dot equals, so we're reassigning a value to living area, and I'm saying living area dot equals sample living area. Okay, so if I do this, okay, and if I compare then our test set with our scramble test set, okay, if you look at this living area column here, you'll observe that basically the values in test.scramble have been all mixed up. They've been permuted compared to their values in the original test data frame. Okay, so having done that, we're simply going to compute the new accuracy after scrambling. I said bedrooms here, but let's do it on the living area for now. Okay, we're going to get the accuracy with this living area variable now completely scrambled. Okay, and what we'll hopefully see is that this mean average percent error will have gone up. Okay, remember this mean average percent error lower is better here. Okay, a higher value means that your error is greater. So hopefully what we'll see is that with this variable now no longer in the model, that our model isn't quite as good as before, and so the average percent error went up a little bit. Okay, so let me go ahead and do that. So I'm going to do the same thing. I'm going to make a prediction now in the test scramble data set, and then I'm going to get this mean average percent error, and I'm going to call it mean average percent error dot after. And let me do that. Okay, and if I evaluate these, you can see the mean average percent error before was that 30%, and now my error has gone up substantially to 34%. Okay, and so I'm going to simply, this step here simply prints the difference between those two things. Got an E. Okay, and you can see basically that removing the variable from our model led the error to increase by something like 5%. Okay, and if I want to do this with a different variable, then I simply choose a different variable to scramble. Okay, so for example, if I wanted to look at bedrooms, okay, the only thing I have to change is this line right here where we select the variable that we're scrambling. So I'm going to change this. Let's say I change this to bedrooms. Okay. Run all that same code again. Okay. And you can see wow. It looks like it changed by a whole lot. Let's see, is that right? Mean average percent error before, mean average percent error after. Okay, so it looks like the error went up tremendously if I omit this bedrooms variable. Okay, so by this metric at least, it looks like bedrooms is a more significant variable than the living area. Okay, which is actually quite different than what we found with our random forest model. Okay, so so I think that's a good stopping point, and I'll see you guys in the next video.